Two players A and B alternately keep rolling a fair dice. The person to get F6 first wins the game. Given that player A starts the game, the probability that A wins the game is, so A first starts the game, then B plays, again A plays, then B, then A. That's the way they play the game. Now, we need to find the probability that A wins the game. So A can win in these many different ways, and it continues. The first way is A gets a 6 in the first chance. A gets a 6 in the first chance, which means that the probability is 1 by 6. To get a 6 out of 6 different options, I have 6 different options for a dice, of which 6 is one such option, so my probability is 1 by 6. Now, another way for A to win the game is, first A plays, A gets a non-6 number, a number other than 6, followed by B gets a number which is not 6, otherwise B will win the game. The third chance A gets 6, which means that I have to find the probability of A getting a non-6 number. The first chance, which is 5 by 6. In the second chance, B gets a number which is not 6, so the probability is 5 by 6, because I have 5 numbers which are other than 6. So 5 by 6 is the probability, into the chance of getting 6 in the third chance is 1 by 6. Again, A can win in such a manner that A gets a number other than 6, B gets a number other than 6, A again gets a number other than 6, followed by B gets a number other than 6, and finally A gets 6. So this is nothing but 5 by 6 into 5 by 6 into 5 by 6 into 5 by 6, right? 5 by 6 raised to 4 into 1 by 6. So this is nothing but I have and now this is now here in one step A wins, here in 3 steps A wins, then here in 5 steps, in 7, like that it will be continuing. Now the probability that A will win is either in 1 step A can win, or in 3 steps A can win, or in 5 steps with these probabilities. So I have, since that I have said or, I have to add these things. So what it means is that I have to add 1 by 6 with, this is nothing but 5 square by 6 cube, right? This is 5 square divided by 6 cube plus 5 raised to 4 divided by 6 raised to 5 plus etc. Seeing this, I can say that this is nothing but a geometric progression with 1 by 6 as the first term, 1 by 6 as the first term, and 5 square by 6 square as the common difference, because here I multiply 5 square by 6 square to get the next term. Again, if I multiply 5 square divided by 6 square, I get 5 raised to 4 divided by 6 raised to 5, like that. So I know that the sum of, now I am going to find the sum of this GP, the sum of infinite terms, sum up to infinity of a GP is A by 1 minus R, where A is the first term and 1 by R is the common difference, the common ratio. So my first term is 1 by 6 divided by common ratio is 1 minus 5 square by 6 square, right? My common ratio is 5 square divided by 6 square, which is nothing but 25 divided by 36. So this gives me the answer 36 minus 25 is 11. 36 divided by 6. So 6 by 11 will be my answer, which is option D. A fair coin is tossed n times. The probability that the difference between the number of heads and tails is n minus 3. So I have to find the probability that the difference between number of heads and tails obtained is n minus 3. So these are those n tosses, right? A fair coin is tossed n times. Now I know that the difference between head and tail is n minus 3. Heads minus t is n minus 3. I have to find the probability for this. And I also know that h plus t, h is the number of heads and t is the number of tails. The difference between number of heads and tails is n minus 3. But I know that h plus t must be n, because if I have 2 heads and the remaining are tails, if I add all the heads and tails, I must get n. So this is n. Now if I add these two things, I will be getting 2 heads is 2n minus 3. So if I divide the entire thing by 2, n minus 3 by 2. Now n is the number of tosses, which means that it is a natural number, it is a counting number. Whereas 3 by 2 is a fraction. I cannot have number of heads as a fractional number, right? Which means that I can never have such a thing that number of the difference between heads and tails is n minus 3, which means that the probability must be 0. Consider a dice with the property that the probability of a face with n dots showing up is proportional to n. The probability of the face with 3 dots showing up is. So what it means is that probability of n dots showing up is proportional to n. So k is the constant of proportionality. So what I can say is 2 is twice more probable than 1. 3 is thrice more probable than 1. That is what it means. 3 is 1.5 times more probable than 2. That is what it means by proportional. Right. Now, what I can say is the probability of getting a face with 1 will be k into 1, which is k. Now, probability of getting 2 will be k into 2, which is 2k. Right. Probability of getting 3 will be 3k, because k is the constant of proportionality. Probability of 4 will be getting 4 will be 4k. Probability of getting 5 will be 5k, and that of 6 will be 6k. Now, what I can say is when I add these things, I must get 1, because in a dice I have 6 faces, so I cannot have a 7th face, which means that if I add these probabilities, the total probability must be 1, which means that if I add these probabilities, I must get 1. So I am going to add these 6 things, which means that I will be getting, so 21k, the sum of these things is equal to 1, or k is 1 by 21. Now I can find the individual probabilities. Right now I am supposed to find the probability of the face with 3 dots showing, which is this thing. So it is 3 into k is 1 by 21, which is 1 by 7. So the probability of getting a face with 3 dots will be 1 by 7. Let x be a random variable with probability density function f of x is 0.2 for mod of x less than or equal to 1, 0.1 for mod of x lying in between 1 and 4, and 0 otherwise. So you need to find the probability p of x, x lying in between 0.5 and 5. So the first thing is you have to draw the graph, and it is always easy to solve such problems graphically. So the first thing is mod of x lies in between, mod of x is less than 1, which means that if x is 0, definitely it is less than 1. If x is 1, again it is less than or equal to 1. X is equal to minus 1, it is again less than or equal to 1, because mod of x is mod of minus 1 is 1. Whereas if x is 2, it is not. So between minus 1 and 1, when I say that mod of x is less than 1, it means that it lies between minus 1 and 1. So between those two values, the value of function is 0.2. Now the next thing is mod of x is greater than 1, but it is less than 4. So in the positive side, this is greater than 1 but less than 4. Again in the negative side, mod of this value, when I take minus 2, magnitude of minus 2 is 2. It is greater than 1 but it is less than 4. Minus 3, mod of that is 3, which is greater than 1 but less than 4. So up to minus 4, this value will be 0.1, and from 1 to 4, this value will be 0.1. This is the function f of x. Now, if you, though it is not required for this problem, if you just want to check whether this is a valid PDF, you know that the integral from minus infinity to infinity of PDF will be 1. Here there is no value from minus infinity to minus 4, and from 4 to infinity there is no value, it is 0. So all I am bothered about is the integral value of this function between minus 4 and 4. And when you integrate a function, what it means is that you are finding the area. So if I want to find the area of this thing, though it is not required for the question, I just wanted to prove that this is a valid PDF. Now if I drop a perpendicular from here, I will get a rectangle here, and I know that the area of this particular piece of rectangle will be, this length is 1 and this height is 0.2, which means that area will be 1 into 0.2, which is 0.2 plus. Now when I consider this particular area, this length is 3 and this height is 0.1, so 3 into 0.1 is 0.3, 0.3. So in this half, the area is 0.5 and this is symmetric. So in this part also the area will be 0.5. When I add those two things, I'll be getting 1. So this is a valid PDF. Now the question is to find the probability that the random variable takes value between 0.5 and 5. So this is the 0.5 point. This is 0.5. Now only up to 4 when I want to find the probability that a random variable takes a particular value in a limit, what I am going to do is in that region or within that limit I am going to integrate the PDF. Right, I am going to integrate this particular function. So instead of going for integral, I can directly find the area. So from 0.5 to 4, I have a non-zero area, but from 4 to 5, I don't have an area because the function is 0. So actually, this is nothing but P of x lying in between 0.5 and 4. Both these things are same because I don't have a value for x values taking a value which is higher than 4. Right. So I'm going to find this area. So this area, same as the way I calculated the total area, I can just break it down. So this length is 1 by 2 or 0.5, whatever it be, 0.5 into 0.2. So this area will be 0.5 into 0.2, which is 0.01. Sorry, this is 0.1, right? 0.1. This is 0.1. And now I am going to find the next area. This area will be 3 into 0.1, which is 0.3. So my probability, the required probability will be 0.1 plus 0.3, which is 0.4. So my answer is 0.4.